Hello, this is Jeff Hamrick at Rhodes College. We need to finish the calculations necessary to estimate the lower bound of the confidence interval for the proportion of heads, the true proportion of heads, that we'll see when we spin a coin. We've already established that the upper bound of the confidence interval can be estimated to be 45%. Let's continue with our calculations by changing this to a value below 41%, like let's say 40%. Now when we do this, a couple of odd things happen. For example, the blue line is now strictly to the right of the middle of this distribution, which means our empirical p-value is going to be a little bit funny now. Now doubling it gives us values over 100%, which should suggest that something is wrong to you. What's wrong here is that this formula for the empirical p-value needs to be updated. We need to change this so that we sweep out the right tail of the probability distribution. Okay? Now this is something that's a little bit more sensible, because when we double this, that's still reasonably interpreted as a probability value. It's about 40%. That's way larger than 0.05, our significance threshold. And so we will not reject the null hypothesis that the true proportion of heads that we see under coin spinning is equal to, what was it? 40%. We need to go lower. How much lower? I don't know. Let's continue. Let's be bold here and skip to 38% and see what happens. When we skip all the way down to 38%, I get an empirical p-value of 0.03. Now when I double this, I get 0.06. That's greater than 0.05, suggesting that we don't have enough evidence to reject the null hypothesis that the true proportion of heads we see under coin spins is equal to 38%, okay, or 0.38. It's possible that this happened due to random chance. If you're uncomfortable, there are two things you can do. You can rerun this as is. Okay? Nope, looks like the conclusion would be the same. Or you could increase the number of measures that you collect. It'll slow things down a little bit, but that's a perfectly fine approach to take. When we collect 1,000 instead of 500 measures, what do we get instead? We get 0.023. Okay, now when we double that, we get a value that's less than 0.05, suggesting that 0.38 is probably a borderline case, actually. So let's run this a few more times. I'm actually going to greatly increase the number of measures we're collecting so that we can really focus on estimating clearly the empirical p-value for this lower bound for the confidence interval. Now when we collect 2,000 measures, I get an empirical p-value of 0.0205. When we double in that case, we get a value strictly less than 0.05, suggesting that we would reject the null hypothesis that the true proportion of heads is equal to 38%. So I don't think that 38% belongs in this confidence interval. I'm going to declare 38%, 39% instead, excuse me, to be the lower bound of the confidence interval. We can check that quickly by changing this to 39% and collect 2,000 measures. When we do that, what happens? We get an empirical p-value that's clearly going to be, when we double it, way over 0.05. So clearly 39% is definitely in the confidence interval. If we want to, we can check quickly, switching the formula for the empirical p-value again quickly, we can check that 45% one more time using the higher number of measures. When I check 45% now, what happens? Let's see. All right, when we double this quantity right here, we get an amount that's greater than 0.05. So 0.45 is clearly inside of our confidence interval. I'll leave it for you to check this, but if you try to check really quickly here, 46%, you'll see that you get an empirical p-value such that when you double it, you don't exceed 0.05 most of the time. So 0.46 does not belong in the confidence interval. So I would argue that the confidence interval generated by randomization procedures is between 0.39 and 0.45%. Stated differently, we are 95% sure that the true population proportion of heads we see under coin spinning is between 39% and 45%. Clearly, it doesn't include the value of 50%, so spinning a coin does not fairly produce equal proportions of heads and tails.